Yes, the topic is orthographic projection of the subject engineering graphics applicable for students studying BE BTech first year. Look onto this diagram. It's a three-dimensional drawing or the representation drawn on the marker board. A similar diagram may be given, 3D diagram may be given. It may have different size, shape and all. The concept is what I'm going to tell at now. So look onto this diagram. This will be the length of the object, 110 mm. This will be the breadth of the object shown is given as a 40 mm. And the overall height is 15 will be the base part. Base part thickness is 15 mm plus another 40 mm. So 15 plus 40 will be 55 mm will be the overall height of this object. So the corresponding model is shown in this video. Okay, this is a model which made using cardboard and chart paper of different color. The length is 110 mm, breadth is 40 mm, and height is overall height is 55 mm. Okay, this is called the base part of the object. Shown top surface as yellow in color, and thickness of the base is shown blue in color, and this having a curvature, inner curvature and one outer curvature is there. Shown outer curvature is shown as rose in color, and the inner curvature is shown yellow in color. Okay, and in addition to that, it has one triangular portion shown red in color, what is called green in color, and the thickness of the triangular part is shown blue in color, and the top land, this part between the inner and outer curvature, it is shown by red in color, and the thickness of the red portion will be outer radius minus inner radius. 20 minus 10 will be 10 will be the thickness of this part. This part thickness is 10, and similarly this here also will another 10 mm. Okay, so now I'm going to draw the front view for this. So usually the object will be placed like this, seeing the length, breadth and height. So now I'm going to turn the object according to this arrowhead direction. This is the front view direction, that is this is the front view direction. So in the front view you can see the length and height of the object. So I turn the object so that you can understand the concept of front view. Another name for front view is elevation. Now you can see the base thickness, blue in color, and this height. Okay, so this yellow surface will be merged forming a single top edge. That you have to understand. Okay, now you can see the base, length and the height of the object. The yellow surface will be merged forming a single line on the top base edge. Okay, that you have to understand. This because the arrow is should be perpendicular to the plane of projection. Like that you have to assume. Okay, in the examinations the block and all will not be given. Only the diagram may be given for purpose of how far you are well versed in drawing the diagram, converting 3D into 2D diagram. So now I'm going to draw the front view. This forms the base as a, you can see the base as a rectangle. Okay, the length of the rectangle will be 110 mm. Draw XY line using the longer scale of a drafter and HB pen. Take your HB pencil, draw object line. That blue color edge that I'm going to construct. Okay, so take any point on the XY line, draw one horizontal line equal to the length of 110. 110 is 11 centimeter. Okay, and the thickness of the base is 15 mm, and construct one longer rectangle like this using HB pencil as it is object line. Okay, next the thickness of next I'm going to construct this 40 mm height. This height is 40 mm above the base. 40 mm means a 4 centimeter. Draw vertical line. Now enclose this top surface. Next, let us dimension this. Base thickness is given as a 15 plus 40. Draw dimension line, then you draw extension line. Put two narrow arrowheads at both the ends of the line. Shade it. This is base thickness 15 plus 40. The length of the arrow shall be greater than the width of the arrow. 40. And the length of this object is 110. So this dimension line and the extension line, this is extension line and this is a dimension line, shall be drawn by using thin HB pencil. I mean thin HB pencil lead. Don't write mm, just you write the number in terms of millimeter. Okay, base thickness and the length is seen in the front view, shown blue in color. Okay, next this rose color part length, we don't know how much it will come. Later we'll complete this front view. It's incomplete now at this stage. So take 2H pencil, draw projection lines traced from the previous front view. Now I'm going to draw the top view. So earlier the object was placed like this. Okay. So now looking from the top, the observer can see the yellow surface. So I turn the object so that you can see it in the camera. The view obtained is called as a top view. You can see the top view. So this is the top view direction. You can see this yellow portion, this part is curvature, and this red color portion lying at the top surface of this 3D object. Okay. And in addition, there is a blue color part. There is a triangular part can be seen as a smaller rectangle shown blue in color. This part you can see, and you can see this hollow passage. Circular passage, a semicircular groove you can see. That is, this is a passage, okay. This base part of the circular groove, semicircular groove, you can see it. So now you can see the length of the object and you can see the breadth of the object. The breadth is given as the 40 mm. Somewhere below the front view, take anywhere this diagram should be drawn below the exactly, but it should come exactly below the front view. Draw a horizontal line. This forms the top view, and the 40 mm is 4 centimeter. Draw a rectangle like this. Okay. So breadth is given as 40 mm. This is the breadth of the object seen in the top view. So let us dimension this. You can use a draft scale itself. Here I use marker board and mini drafter. Same principle is followed when you draw it on the drawing sheet. Put into two narrow arrowheads at both the ends of the line. Shade it and you can write the breadth as 40. Okay. Next is the end of this curvature. There is one curvature seen in the top view. This curvature radius is given as 20 mm. So the 40 divided by 2 will be 20 mm. Along this breadth of the object, draw one center line. 40 divided by 2 will be the lighter line you draw, so that this above the center line will be 20 plus 20. Okay. This line where it intersects with this vertical line, there you mark the radius of the arc. Okay, 20 mm. So this distance will be also 20 mm. Same as the curvature, 20 mm. This 20 is taken. From this end point as reference, mark and point at a distance of 20 mm. From here, this distance is marked as 20 mm. This distance is 20 mm. Equal to radius of the arc. Take your compass. With this center as reference, draw a semicircle at the right end of this object. Okay. And the remaining portion shall be erased. This curvature is the right side curvature on this object. Radius is 20 mm. With the same point as reference, with the same point as center as reference, draw a circle equal to the diameter of the hole. So it's given as a pi 10. Pi is a notation used to indicate the diameter of the circle. So radius will be 5 mm. Take compass or pro circle, complete this circle. Okay. So next we are going to dimension this. So release your drafter scale, rotate in anti-clockwise, set an angle to 45 degree. Draw a leader line. from the center of this circle, inner circle, and another leader line to denote the outside radius of the semicircle. Then reset your drafter scale. Rotate in anti-clock scale will be released. First drawn line is the XY line. Keep the longer edge over the line, longer scale over the line. Rotate the nut in clockwise. We will be holding the scale. Draw a horizontal line, one at here, another one at here. So now I am going to denote the inner circle as in terms of diameter. Put it to narrow it outside the circle. As the size of the circle is smaller, from here to here is the diameter of the inner circle. So pi 10 is written. Okay. Next, from here to here is the radius of the outside left hand side arc, R20. Right, in terms of radius, so R20 is written. Okay. Next, on the left hand side you can see inner semicircle and outer semicircle. Red color portion thickness is 10 mm as I told earlier. Extend is center line using the longer scale of a drafter. Where it intersects with this vertical line, this point center as reference. Using compass, draw two semicircles. Inner semicircle radius is 10 mm. Take 10 mm in your compass with this center as reference. Draw one semicircle. Here I use marker board. The same principle shall be followed when you draw it on the drawing sheet. Okay. Next take 20 mm in your compass. That is the 40 divided by 2 will be 20. Or you can take directly from the scale measurement. 20 mm with the center as reference, center of your compass. Draw one outside semicircle of radius 20 mm. Okay. So this will intersect with this 40 mm line. Here I use marker board. Okay. So let us dimension this by means of leader line. So set it to an angle of 45 degree. Whenever you rotate the scale, release your nut. Hold the scale and rotate the nut in clockwise. Release it, then you rotate the nut in clockwise. Draw a leader line, 45 degree inclined line like this. One for inner circle and another line, leader line for outer circle, outer semicircle. Okay. Then reset your drafter scale. Draw a horizontal line. Inner radius is 10 mm. From here to here is the radius. So R10 is written. R10. Our outer radius is 20 mm. Here to here is the radius. So I use the notation R for stand for radius R20. The length of the object is same as the front view length. You need not to interpret the same. Already previously it is marked in the front view itself. Okay. Need not to repeat the dimension. Okay. Next, draw vertical projector. Now I am going to complete the front view. So for front view, this is a portion of the object. You can see the length and the height of the object. The green color part from here to here is given as 30 mm. 30 mm means 3 centimeter. Before that, we will complete this rose color part vertical edge. One on the right side and one on the left hand side. This rose color part. Okay. So draw a vertical projector from the previous front view. This is the outside arc, outer semicircle. Draw with this point as reference. Draw vertical projector where it intersects with the top surface of the base. This is top surface of the base. Okay. There you draw vertical line. This forms the rose color part. This is the boundary of the rose color part here. Okay. After that, there is one green color portion. Length is 30 mm. From here, you locate a point at any distance of 30 mm. Put a point. Join with the top corner of the outer arc. This arc, outside arc. Okay. Use the freehand scale. Yes, completed. The view obtained is called as the front view. Earlier it was incomplete. Now we are completing this front view. In the front view, you cannot see this hollow passage. But something is passing inside. That has to be indicated in a diagram. The correction is to be made. Okay. So this is the front view direction. the front view direction, this hollow cannot be seen, but it is available. That can be indicated in the diagram by means of leader line, by means of dashed line. DASHED, dashed line. You project the diameter of the circle from the previous drawn top view where it intersects with the base part of the object. There you draw two parallel dashed lines. Line gap, like that is called a discontinuous line to show the hidden edge. That is something is passing inside. That it denotes. So next this yellow color portion, the inside curvature. This something is a hollow is there, and red color portion thickness is 10 mm. So in the front view you have to keep like this. This is the front view direction. Observer can see the length and height. This hollow is there. Suppose if you leave as it is, it means that's a solid is there. Solid means no, not a hollow. Hollow is not available. But here some hollow is there, semicircular groove is there, passage is there. So that has to be indicated in the diagram by means of leader, what is called as a dashed line. So draw from the previous inner circle radius. This is inner circle. So from this point as reference, draw vertical projectile using 2H pencil, where it intersects with the top surface of the base. See, above the base only this passage is there. Hollow passage is there above the base part of the object. Okay. So that has to be indicated in the diagram by means of dashed line. It's a discontinuous line drawn called hidden edge. Not seen in the front view, but it is available. That has to be indicated in the diagram by means of dashed line. Usually dashed line will not be dimensioned, okay. That you have to understand as the rules to be followed. This is center line along the length of the object. Next we go for side view. See, earlier the object was placed like this. Okay. Now this is the front view direction. For this arrow direction, this will be left hand side. So looking in this direction, the observer can see the breadth of the object and you can see the height of the object. So I turn the object so that you can see it in the camera. You can see the base, breadth and height of the object. Okay. This yellow surface on the top surface of the base will be merged forming a single base edge. That you have to understand. So this base breadth you can see, and you can see the overall height of the object. So take this end point of the front view as reference. Turn your protractor, draw one 45-degree inclined line called as meter line. Read like this, 0, 10, 20, 45, put a point. Join it by freehand scale. For meter line you can use a 2H pencil. This is a hard pencil. Will be lighter line. Next, using a drafter scale, draw horizontal projectors from the previous top view. Okay. Where it intersects with the meter line, there you draw vertical projector using the vertical scale of your drafter. Then you extend the top surface from the previous front view. Draw horizontal projector using 2H pencil and longer scale of your drafter. Base thickness, there you draw horizontal projector. So this forms the boundary for the side view. Boundary corners for the side view. Inside this only the side view will rest. Okay. So this is the base part of the object shown rose in color of equal to breadth of the object. This 40 mm seen in the top view will be same as this turned. Okay. So using HB pencil, you show the edges forming a rectangle, rose color part. It's called the base part of the object seen in the side view called the left side view. Left side view shall be drawn on the right side of the front view following first angle projection principle of the method. Next, this blue color part, this length will be equal to the thickness of the red portion. This is 10 mm. This 10 mm follows here and here, another 10 mm. So with this corner, from this corner, mark 10 mm and enclose this vertical rectangle. One on the left side, another one on the right side. So if you use a drafter scale, you will get a perfect answer. And you can save the time also. The diagram will not go cross. That is the advantage of mini drafter. Okay. So let us dimension this. You can see the breadth of the object equal to 40 mm. Automatically you can get this distance by using meter line. Projection using meter line. Projecting using meter line. Okay. The breadth of the object is given as a 40. Put a narrow arrow, shade it, right 40. And the base thickness is 15 mm, already we mentioned in the side front view. Okay. Then the overall height of the object is 55 mm. 15 is the base thickness and plus 40. Or you can put the overall height also. Overall height is 40. Okay. So next this is 10 mm, another 10 mm. Let us dimension it using extension line and draw dimension line. Put a narrow arrowhead, shade it. The length of the arrow shall be greater than the width of the arrow. 10 shall be written center of the dimension line above it. Okay. Next, this hollow is to be indicated in the diagram. This one hollow passage is there, diameter 10 mm. This is passing inside the base part, but not seen in the side view. Something is passing inside along the breadth of the object. That has to be indicated in the diagram by means of dashed line. We'll project from the previous front view, what is called as a top view. So this is a hole size equal to diameter. Draw two parallel projectors using 2H pencil and the longer scale of it. Where it intersects with the meter line, there you draw vertical projector. So the circle passes only on the base part. So there alone you draw a dashed line. Okay. So this is a portion where the circle passes or the hole passes. Okay. Only on the base part. Next, this yellow surface on the top. Yellow surface, this you have to close it. Okay, here it is drawn by 2H pencil. You enclose this using HB pencil. So this part denotes, this is that part shown yellow in color. Right side blue, left side blue. This is corresponding that. Okay. And one more correction. This yellow color, what is called a green color portion. So looking in this left side view direction, the observer cannot see the triangular portion. But something is there along the height of the object. This blue color part, the thickness is given as 8 mm. That has to be shown in the diagram. This 8 mm thickness. Okay. It's not seen in the side view, but it is available. Back side, lying at the back side. So you locate one center point. 40 divided by 2 will be 20 mm. Put one center point. This is 20. This is another 20. 20 plus 20 will be 40 mm. Draw a reference line at this passing through this vertical, passing through that point. Okay. So next, the thickness of the triangular part is 8 mm. 8 divided by 2 will be 4 mm. So left side 4 mm, right side 4 mm, put 2 points. And along this marked point as reference, draw a dashed line to show the triangular portion thickness. Okay. Yeah, it's completed. Later again, if you want, if you can erase this reference line. Okay. Now the overall height of the object is same as the front view height, 55 mm. Breadth of the object is 40 mm. Okay. Yeah, it's fully completed. So now you can write the name of the diagram. Draw 2 guidelines for uniform height of letters. Using your HB pencil, you can write the name of the diagram. This is the front view. Exactly below the front view, top view diagram will come. That you have to know it. Next, this is a left side view drawn on the right side of the front view following first angle projection principle. Left side view. Okay. So next, right side lower part of these three diagrams, draw two guidelines and you can write common representation. All dimensions are in mm. Millimeter is the unit followed. Okay. Yes, completely looks correct. And next, this 30 mm need to be dimensioned. 30 mm, you can mention it in the top, what is called as a front view. This distance is 30 mm. Already we marked 110 at the base part of the object. So you can draw it at the top. Okay, draw extension line. Then you draw dimension line, put it to an arrowhead, shade the arrowheads. See, inside the diagram, usually the dimensions will not be done. That you have to understand. Okay, this is 30. So in the front view, you can see the length of the object and height of the object. Length and height. In the top view, you can see the same length of the object and breadth of the object. Then the breadth. The side view, you can see the breadth of the object and height of the object. Breadth, height. Okay. Yeah, thanks for listening. Yes. Yes, the topic is orthographic projection. For the given three-dimensional representation, the corresponding front view, top view is shown in this simple video. So this is how the drawing appears when drawn on the drawing sheet and using correct grade of pencils. So looking in this arrowhead direction called the front view direction, observer can see the length of the component and the height of the component. That is indicated in the diagram. 2D representation is called the front view, drawn above the reference line called as the XY line, showing the length of the object and the height of the component or the object. Okay, this dashed line represents the hidden edge of the hole passing inside the object. Okay, the corresponding top view is also shown and it is drawn exactly below the front view. So looking from the top, the observer can see the top surface. That is two semicircles, smaller semicircle and one outer semicircle, plus this curvature will be radius. Its size is not given. As I am taking this outer radius of this bigger semicircle, that is R20, same distance you can take it for while drawing the diagram. This is R20. So looking onto this diagram, the shape of the curve is same as this. So if any dimension is missing in the diagram or 3D representation, you can assume suitably. And exactly below the front view, the view obtained is called a top view. And this smaller semicircle, this larger or bigger semicircle, its radius, its size is mentioned in terms of radius. This R stands for radius. From this center point of the semicircle to this extreme point is radius. So one arrowhead is mentioned. And that stands for radius of the outer arc R20, 20 mm, and the inner semicircle as radius R10 is written. 10 mm is the radius of this inner circle, semicircle. And while looking from the top, the observer can see this hole. Okay, across the length of the object. Its size is pi 10 is written. Pi means a notation used to denote the diameter of the circle. So it appears like this, and it is indicated in the diagram. The size is mentioned by using leader line, inclined at 45 degree, mentioned as pi 10. And further, for this arrowhead front view direction, this will be the left side. So looking in this direction, observer can see the left side view, that is showing the breadth and height of the component. That is represented, left side view is mentioned or represented on the right side of the front view following first angle projection principle or the method. And these lines are called, lighter lines are called as projection lines or projectors drawn from the previous front view. Also previous top view, these projection lines are shown, used to obtain the left side views drawn on right side of the front view. So this is how the drawing appears when drawn on the drawing sheet. That is the very purpose of this video segment. This dashed line represents the hidden edge. Something is passing inside. That can be represented in the diagram like this. Also there is a small correction is there. This dashed line, you will get only this part. This lower edge, and that is on the base. Below the base, that is on the lower surface of the base, you can see two dashed lines like this. This represents the hidden passage of the hole passing for this mentioned hole. Okay, right. So this is how the drawing appears when drawn on the drawing sheet. That is the purpose of this video segment. And the right side lower part, you can write all dimensions are in mm. Mm means millimeter is the unit followed. So for various three-dimensional object, you practice front view, top view, any one side view which is suitably visible from the given 3D view. Thank you for listening. Yes.